Okay, good afternoon, ladies and gentlemen. So today, our objective for today is that students will be able to determine the volume of a cylinders, cones, and spheres. It's like we call a typo there. That should just be the volume of cylinders, cones, and spheres. So I'm just doing this video a little bit different today. Instead of using the document camera, I'm going to go through it on my laptop, just like you're going to see it when you guys click on the assignment, so that I can show you how you can go about just showing your work and typing some of the math in, okay? So far last week, we were looking at different shapes. We looked at cylinders, we looked at cones, we looked at spheres in that order, and you guys started practicing just figuring out what the volume of each sphere would be, if you know what the radius was, if you know what the height was. So today, we're gonna actually, again, just examine that relationship a little bit more between cylinders, cones, and spheres, and specifically, we're going to look at spheres, cones, and cylinders that all have the same radius and the same height. So for example, right, let's say that the radius of this cylinder here was like 2 centimeters, right? That means that the radius of the cone here is going to be 2 centimeters. Radius of the sphere here is also going to be 2 centimeters. So they're kind of related, right? Also, we're going to say that they have the same height. So if this here had a height of, say, 6 centimeters, this one here would also have a height of 6 centimeters. This one here would also have a height of 6 centimeters, okay? So first thing we're gonna do is we're gonna look at an example. So I'm saying that I have 3 shapes, a cylinder, a cone, and a sphere, right? Again, we're gonna specify that they all share the same radius and the same height, but I'm not telling you what that radius and what that height is, right? Just that they have the same. Now, based on what you see here, I want you to answer these 3 questions that you see here. It says, which shape has the largest volume? That should be pretty straightforward. Which shape has the smallest volume? And then, do you notice any other relationships among the volumes there? So, are there any patterns that you notice between these 3 numbers here? All right, so I want you to pause the video, and on your paper there, try to write those out, okay? Type them out. Now, I'm not going to give you these answers here because I want you to come up with them yourself, but when we have a live Zoom session, we'll go around and have people share out what they found, okay? Now, if you've got some extra time, a bonus would be, can you actually try to figure out what the radius and what the height are for each of those 3 shapes, okay? Now, we're moving on. And again, I have another example similar to the last one, but these numbers might be a little bit easier to comprehend. So I have another cone, cylinder, and sphere, and these are the listed volumes. So again, you're gonna answer the same set of questions that you just did. First, which one has the largest volume? Which one has the smallest volume? And then, do you notice any other relationships among the volumes? So I want you to really try to be specific here. What relationships do you see between these numbers, right? Then, once you figure those relationships out, I want you to scroll back and look at these up here, right? You might notice a pattern in these numbers here that wasn't easy to see in these numbers here. So just verify, do they work, right? So if you notice some sort of relationship between, say, a cylinder and a cone, does that same relationship seem to hold up here, talking about this cylinder and this cone, right? After you've done that, I want you to try to verify what you just did. So this here, this is a little tool that you can use. You can click on the link here. That's going to allow you to fill up different shapes and pour them into other shapes. Because remember, volume is a measure of how much stuff fits inside of a shape. So it says, get started by dragging a shape to the faucet to fill it. Shapes that are filled can be dragged onto other shapes and poured into them. So we're focusing on the top 3 here, right? We've got a sphere, we've got a cylinder, we've got, a cone and a cylinder. At the bottom here, you're not going to worry about those, but I'll just show you an example. So for instance, if I drag the pyramid over here, you're going to see it fill up. And now I can use the pyramid to fill up other shapes. So I could drag it on top of here. That's going to fill that up there, right? So that completely filled the cone. I've got a little bit of water left over here, right? So one relationship between these 2 shapes is, let's see how many times I can fill up the pyramid and use the pyramid to fill up the cube. So I filled it up once. I'm filling it up twice. Now I'm going to drag this into the cube. And it looks like I can do it one more time. And there we go. Now you can see here that this cube is actually full. So it looks like if I took 3 pyramids, I completely fill up 1 cube, right? So you're gonna see, are there any other relationships that are similar between these shapes here. Play around with it, look at the numbers, see if you notice any patterns. And then we're going to discuss them during the live session, okay? Now, after you're done with all of that, you're going to go ahead and just do some more practice with finding the volume of cylinders, cones, and spheres, okay? So we're assuming that they all have the same radius, the same height. So I'm going to walk through this first example for you here, and then you're going to practice the rest of them yourself, okay? So I gave you all the equations that you need. The volume for a cylinder is here, the volume for a cone is here, the volume for a sphere is here. So I'm going to start off figuring out, okay, what's the volume for a cylinder that has a radius of 2, a height of 4? Now, what I can do here is I can actually copy this equation, paste it down here, right? Now I'm going to show you how you can actually do this yourself, right? Let me show my work here. So again, I'm going to just paste it again, but I'm now going to replace my measurements. So it tells me the radius is 2. So this 2 is going to replace the 2 here. So I'm just going to delete that R, replace it with the 2. Same thing with the height. The height is 4, so I'm going to replace this here with a 4. So that tells me how to find my volume. It's going to be pi multiplied by 2 squared times 4. Now, at the bottom of the page here, I actually have a link for a scientific calculator. So if you click on this link here, that's going to open up your browser to a new window, and it's a calculator that you can use. So let's go back and see what I need to do. I need to do pi multiplied by 2 squared times 4. So pi is right here, or I can type pi. Now times, I'm going to hit the star key. That's for me, shift 8, or you can hit multiplication here. So pi times 2 squared, so 2. Now to get the exponent, what I'm going to do on my keyboard is I'm going to hold shift and press 6 to get that up arrow. That brings you to the exponent here, right? Another way that you could do that same thing is this button right here, a squared. So if I push that, that's going to square it. Or if I need a different exponent, this key here that says a to the b is going to let me choose whatever number I need. So pi times 2 squared, I push the arrow to the right, multiplied by our height, remember, was 4. And boom, here's my answer right here. So 50.26, this is a 5, so I need to round this guy up to a 7. So 50.27 is my final answer. So I'm going to say over here, V is equal to 50.27. My units are cubic inches. So cubic inches, right? That's my work. Now, same thing for the cone, right? Let's copy this formula down, paste it right here. And again, I'm using the same exact radius, the same exact height. So my radius here is 2. My height is 4. Now I need to just go back to this calculator. So I've already got this in here, right? Pi times 2 squared times 4. Actually, the only thing that I need to add in here now is this 1/3. So I'm going to go to the front here, and I'm just going to type 1 divided by 3. And it gives you a fraction right here with the calculator. So 1/3 times pi times 2 squared times 4 gives me 16.755. So I'm going to round that up to a 6. So in this case here, I'm going to say my volume is equal to, 16 point, let's double check that, 76, right? And cubic inches. Now, lastly, same thing. Let's start with this formula here. Copy, paste, right? I forgot to actually copy and paste the formula down here before I changed it. So in this case, all I need to change is the radius here. I actually don't need the height when I'm talking about a sphere. So I need to just change this number here to a 2. So it's 4/3 times pi times 2 cubed. That's going to give me my answer. And again, this is very simple if you have this calculator up. So I'm going to change this 1/3 to a 4/3. I need to delete this 4 here, and I need to go over here and change my exponent to a 3. So 4/3. Now, I don't have multiplication here, but you'll see that if I actually add it, it doesn't change my result. So being next to it is the same thing as saying 4/3 times pi times 2 to the 3rd power, right? Let's make sure everything's correct. Here's my answer right here, 33.51. And you can also copy and paste right from here. So 33.51. And again, my volume is cubic inches. Now, if you're tired of writing out the words cubic inches, what you can actually do is go to insert, equation, get inside the equation editor. So I can now here type inches, and it, just like I did before with the exponent, I'm gonna hold shift, press 6. That's gonna get me to the exponent. So now I have cubic inches, right? And this equation editor here is the same thing I use to write these expressions here. You see that light blue box going around the outside? That's what I get from the equation editor. So if I went to a new line here, now I can hit new equation straight from there, and I could type out whatever I want. Okay, so what you're gonna do is, the remainder of the time, you're gonna practice using the scientific calculator along with showing your work here. So like at the minimum, we should have these 3 things here, right? You should have the equation you started with, what you have once you substituted in your radius and your height, your final answer with the correct units. Please try not to forget your units, right? So this one here, I just neglected to add that equation in. So let's just copy and paste that for the cone. There we go. So again, try to have at the minimum these 3 steps. Your equation that you started with, what you got after you substituted in the radius and the height, your final answer, okay? So take the rest of the class time. If you have any questions, find me on Zoom and we'll help you out there, okay? Now, good luck.